Welcome back, my friends. We're going to go over 5C1. And we're going to start with number letter D. And the idea here is that we want to express these rational these rational expressions as a single complex number in A plus BI format, where A and B are real numbers. So we're going to start with D because that's just a good classic example. And first of all, I want to notice that in the denominator, it's not an A plus BI format like it is with this one and this one and this one. But instead, it's the BI plus A format. And you know what? That's a simple fix, especially because they're all positive. So I'm just going to re-express this as 3 minus 2i over 3 plus 2i. And we probably could have gotten away without even having to do that, but I just like to do things the proper way. So now we need to multiply by the conjugate of the denominator. And in the denominator, we have 3 minus 2i. And if we hadn't put it in proper format, some of you may have gotten it backwards and put 2i minus 3. I just...
Interruption. All wrestlers should be leaving class and going to the bus.
Okay. And we're going to do the same thing on top. I'm not editing this. I'm just going to keep it. It's fine that I don't edit. And we're going to start with the denominator. I want to show you what happens with the denominator. All right, so if we have 3 plus 2i times 3 minus 2i. I'm going to zoom in. Yeah. Then this becomes 9. Slightly different color. Let's do this. 9. This becomes 6i. This is minus 6i. And this is minus 4i squared. But remember that minus 4i squared is minus 4 times, well, I squared is minus 1. So it's minus 4 times minus 1. And that actually just equals positive 4. So I'm going to put in a 4 right here. Now I'm going to add these up. This plus this is 0. And 9 plus 4 is 13. So this denominator is simply 13. For the numerator, we have 3 minus 2i times 3 minus 2i, so we're basically squaring that. And I could certainly just do the, I know the pattern, so I could just write it out. But for your benefit, I will show you everything, because some of these you can't do that, and I want to make sure you do the area model correctly. So we have 3 minus 2i, and we have 3 minus 2i again. And so what we get is we get 9. And here we're going to get minus 6i. And here we're also going to get minus 6i. And here we're going to get positive 4i squared. So 4i squared. But remember, I squared is just negative 1. So this is really just negative 4. And so if we add these together, we get 5 minus 12i. Are we done? Absolutely not, because it needs to be expressed as A plus BI. And that's what I'm going to do right now. You are not done. You have to, if you really want it in the proper format, you have to split the fraction up. You have to write it separately. So we're going to do just that. So the real part here is 5 over 13. So we're going to write 5 over 13. And I'm going to stick with the plus. I don't usually do this. Should I do that? negative 12 over 13 times I. And now we have a clear, right, this is my A, and this is my B, and it's nice and clear that I can see what's the A and what's the B, because I have it in A plus BI format. Which, again, if you think of it as a coordinate, you know, those things are important, that you make sure you delineate those two. You separate them out. Fantastic. Okay, so that's the basic example. That was hard enough, just like the basic one. Now we're going to get into some like crazy ones. So we're going to look at H, I, and J. And maybe they're not so crazy, but let's have a look. I'm also going to need some room. Good thing I have some room here. Okay. I'll leave this here in case you want to see it. All right, we're going to start with H. So square root of negative 8 right off the bat. Square root of negative 8, I hope you all understand, is the square root of negative 1 times the square root of 8. And that just means I root 8. And we could also write this as 2 root 2. You know, I times 2 root 2, depending on what we want to do. Well, if you have it as your answer, you're not supposed to leave it as square root of 8. You're supposed to simplify it as 2 root 2. But sometimes, you know, I don't do that until the very end of the problem. Don't tell anyone. And once I'm done and I submit my answer, then I'll convert root 8 to 2 root 2, just in case it helps me to simplify more easily. Now, in this case, I don't think it's going to happen, but just telling you my habits. All right. So what is this? Well, let's rewrite this here. So we now have 2 plus I root 8. Well, maybe I will write it as 2 root 2. I times 2 root 2 over 1 plus I. No, I'm not going to do that. We're just going to do the classic method. We're just going to plow right ahead. And we're going to multiply this by the complex conjugate. So this is going to be 1 minus I times 1 minus I. And the denominator is going to be, well, it's actually, in this case, I'm not going to do that. I would like to point out that it's the difference of squares, right? It's if you have a plus b times a minus b, then of course that's a squared minus b squared. But it's not a and b, it's 1 and I. So this is 1. Actually, I do this whole thing right here. And the b is I. And what that means is that this is 1 minus negative 1. In other words, 1 plus 1. And you know what that is? That's 2. Wow. And the numerator is fun. We have 2 plus I times 2 root 2. And we have 1 minus I. And so this is going to give us 2. This is going to give us I times 2 root 2. This is going to give us minus 2I. And this is going to give us, I'm just going to go ahead and simplify it in my head. I squared is negative 1, minus negative 1 is positive. So this is just 2 root 2. And so, let's write it all out. This is going to be, unfortunately, we don't get to simplify much. We can factor out a 2, but we're not going to do that yet. So what we get is we get 2 plus 2 root 2 plus I 2 root 2, whoop, minus 2I. And now we divide top and bottom by 2. And we get 1 plus root 2 plus I root 2 minus I. Are we done? Never. Okay. Well, not never, but not like this. Because this is not A plus BI format. So we have to factor out that I. We have to get that right. So so we're going to have this right here plus I times root 2 minus 1. And if you want, I suppose we could, no, it doesn't want to work. How about that? That's cumbersome. No wonder you guys were not liking that one. Whew. Let me just double check, make sure I didn't make a mistake. Yep. Okay. Okay. Yes. Okay, yes, good. I'm just double checking everything. Okay. Yeah, we're good. We did the thing. All right. Wow, fantastic. All right. So that's H. Let's go on to I. How we feeling? Okay, ready to plow ahead? Now I need to erase this because I need the room. So I hope you got everything down. No? Okay, want to take a picture? Or I can just work over here. That's fine. I'll just erase this stuff over here. No. I'm going to erase this stuff over here. Erase everything? Yeah. Yeah, maybe. That's my eraser. She's right, though. Sometimes I use the whiteout. Okay, let's go on to letter I. Or, yeah, number I, whatever you want to call it. Before I do anything, I feel like I should just factor out root 2. So if I factor out root 2, I just divide everything by root 2. I'm going to get 1 minus root negative 25 over root negative 9. And I would like to point out that this is simply 1 minus 5i over 3i. This is I. This is this one right here. And so now, to make the denominator real, do I multiply by like minus 3i, or what do I do? By what? Yeah, I mean, that would be like, hey, if it's 0 plus 3i, if I just multiply by 0 minus 3i and I do the thing, it should get rid of it. But you know what? We actually don't have to, because simply multiplying by I will be good enough. Okay, we're just going to multiply everything by I. I hope you guys caught that. I hope you were all paying attention to that. I didn't do the conjugate because I didn't need to. All I needed was the I. Because the real part, the A, quote unquote, in the denominator was 0. And if the A in the denominator is 0, all I have to do is multiply by I. And that will give me back to reality, because I'm assuming it's just an imaginary number. It's not a complex number in that sense. Well, you know what I mean. And it doesn't have the both parts of the complex system where there's a non-zero for the A. Okay, so if we multiply all this, what do we get? We get I minus 5i squared, in other words, plus 5, over minus 3. Let's clean this up a little bit. So, first of all, I prefer to have the real part come first, so I can say 5 plus I over negative 3, and then I can split the fraction. And this is going to be negative 5/3 plus negative 1/3 I. You heard me. That's what it is. Right here. Thank you. Thank you. I try. I really do. And now, ladies and gentlemen, that was actually a lot faster than H. And actually, when I first looked at H, I thought it would be super simple. So now let's look at J. So we're going to do J. Let's see here. This looks like fun. So for J, I see a bunch of squares in the square roots. I'm gonna do, the first thing I'm gonna do is I'm going to make those square root of 9, for example, make them 3. So this is gonna give me 3 plus 2 over 3i plus 2i. Is it really that simple? I suppose it is. So this is J. This is just 5 over 5i. So this is really just 1 over I. Is that okay? Can I leave it like that? No! I cannot. So I'm going to multiply by I over I. And I'm going to get I over negative 1. Oh my gosh, it's just negative I. Or if you prefer, 0 minus 1i. Wow, wasn't that fun? Okay, well, my friends, thank you for sitting through all that. I hope that was helpful to you, that you learned a little something about how to simplify some of these complex numbers and their rational expressions. Join us next time for more wonderful content. Please like, share, and subscribe. Buy my merch. There's not any real merch. Thank you. Have a good day. Bye.